In Chapter 6, we're going to take a look at understanding the subatomic atom. We're going to take a look at light, waves of light, and photons. And so, for example, this picture of the fireworks here to the right, we're going to kind of get to the bottom of explaining where these colors come from. What do these colors represent with respect to the atom? We looked at the classical view of the atom and Dalton's theories in Chapter 2. Now we're going to get a better understanding, more of a 19th and 20th century view of the atom as we understand it today. So with respect to quantum mechanics, what is the understanding or our understanding of an atom? A few announcements first, right? I've posted exam 2 grades. So the class average was a 70, so it was quite a bit higher than exam 1. Again, though, a significant range. I had 3 students with a perfect exam, and I had students receiving 12, 13, 15% on the exam. So quite a significant range. I did give partial credit for some calculation questions and for the solubility question, so question 5 and the blood alcohol content question. Everyone received 2 participation points for answering that question, for attempting that question. So those questions were split 50-50, correctness and participation. And so, there were some points kind of thrown in to help even out the average and help bring up the score a little bit on those 2 questions, which proved to be a little bit more tricky than we were expecting. I've received many comments about how people think the real exam is too hard, or the questions in the practice exam do not reflect the real exam. And I really struggle to kind of understand this, because many points in getting ready for exam 2, when we would do a mole-to-mole calculation question, I would say, this question will be on the exam. It won't be the same reaction, it won't be the same coefficients, but the process is the same. Or a mass via moles to mass a product calculation question. I guaranteed a question like that would be on the exam, and it was. It was a different reaction than the practice exam, but the process is the same. Limiting reagent calculation. I took the limiting reagent calculation exactly from the practice exam. I changed the reaction, I changed the numbers. The steps, the process were identical. Yes, the numbers were different, the reaction was different, but the process for solving that problem was identical. And the class as a whole, that's where most people struggled on those calculation questions that I said were going to be there. Hess's law, I said a question like that would be there. Summation calculation, I said a question like that would be there. So I'm kind of struggling with what more I need to do, because I said those questions were going to be there. And not only that, they were very similar to the questions in the practice exam, only changing the reaction or the value in the calculation, the process being the same. So please take a look at the practice exam, take a look at the real exam. I can point out many examples of questions that were in the practice exam with very similar question in the real exam, or a question testing the same exact concept. So I think part of the problem and part of the challenge with the exam is we're not working through it together. We're not working through it in lecture or in recitation, and someone's not breaking down the problem for you. And that's what I think we have to work on, is how to break down these problems, because it's easy to follow along and watch a TA or myself break down the problem. And then when we get to the exam and a very similar problem, if you haven't practiced breaking that down yourself, more than just watch a video, you have to actively engage, actively think about the problem, actively write out the steps of the problem, right? Learning is not a passive activity. We have to be active with our learning. So I've read many of the emails. I understand your concern. I understand people are worried about their grade. But when I say in a review session, or going over a practice exam, or going over a problem in lecture, that this will be on the exam, I don't know how much more direct I can get. And every time I said that, I put those questions on the exam. Yes, the reaction might have been different. The numbers might have been different. The steps would be identical for those mole-to-mole calculations, or mass-to-moles, or limiting reagent calculations, or summation, or Hess's law, or even the calorie question. All I did for the calorie question was I changed the peanut butter for the chicken, I changed the mass, I changed the delta T. The steps would have been identical, and yet half the class missed that question. And we did an exact copy of that question in lecture, in review, in recitation, in office hours. So I think for exam 3, we need to look a little bit at how we're preparing for the exam, how we study for the exam, how do we work out problems during homework, during recitation, when we're getting ready for that material. So that being said, right, Module 6, the pre and post lecture are due this Sunday. We're going to start and finish Module 6 this week. I also have to submit mid-semester progress reports. I will base those mid-semester progress reports on exam 1, 2, and the homework. If you're basically close to failing or failing the class at this point, I will just send you a flag that just says, hey, you know, here's my email, here's my office hours, let's meet, let's talk about this. And that's all. I would just, I would appreciate a response of, thank you. Yeah, I want to talk about it. Because that's all I want you to do is just know where you are in the class, know that maybe you are failing or that you're close to failing, and what we can do to change that between now and the end of the semester. So please, I'm filling out these surveys. I'm sending that flag just because I want to connect with you. Find out where you are, how you're doing, what could we do differently for this semester to kind of get you through the course that we've already started. So those emails should be going out Thursday, Friday, Saturday this week, depending on what time I get to do those mid-semester progress reports. Okay, so today we're going to look at a phenomenon that many early scientists did not know how to explain, and that was if you took metal salts and burned them, those metal salts would give off a different color. And so you see the bright red in the upper left-hand corner. That might be lithium. The blue is copper. The green is barium, right? So early researchers, early scientists were trying to explain why do these different elements, when they're burned, why do they give off a different color of light? And we see that today. Every 4th of July, when you go and watch fireworks, that's what you're watching. The colors that are given off by the fireworks are a product of the elemental composition of those fireworks. So different metal salts are going to produce different colors, and that's what we see when we're watching those fireworks displays. It's a product of the color, it's a product of the elemental composition of the salts in that firework. So to get a better understanding of what we're observing and where that is coming from, where are these colors coming from within the atom itself, our learning objectives for this module, we need to understand and explain emission spectra. We need to be able to relate energy and frequency and wavelength to electromagnetic radiation. And we need to understand the photoelectric effect and be able to apply the equation that explains the photoelectric effect. We understand what that means for the system and for the element themselves. And really, at the end of the day, it comes down to this wave-particle duality of light. So we need to be able to understand what that means for light to have this wave-particle duality of, depending on when we're the situation, we might think of light as a wave or as a particle, right? So two different properties depending on the situation we're working with. So before we get started, though, I want to show you this short video. This is a video I did not make. This is a video that I pulled from YouTube, but it's a great example of that demonstration that I was telling you. This is actually a very dangerous experiment, the rainbow flame experiment. There have been many accidents with this experiment because what you do is you take different metal salts and then you add ethanol or methanol to them, and then you burn the metal salts within that solvent of ethanol or methanol. And what tends to happen is people tend to forget to cap the original container, and then the vapors catch on fire, catching the container on fire, causing an explosion, or people tend to take an open container of ethanol or methanol and pour it directly on a fire, which causes the same thing. You ignite the initial container on fire. So we're going to watch this quick video, but during the video, I want you to think about why do these different elements, why do they give off a different color of light? Where could that be coming from? Right, so in that video, we saw different elements, when they're burned, they give off a different color of light. And so just to pull two examples from that, right? Let's look at lithium here on the left. Lithium burns this nice bright red, sodium burns a nice light yellow. And let's analyze that color that's being given off, that light that's being given off. Because if you think about it, before we get too far into this, if you think about the white light that we look at every day, that we live in every day, if we were to take that white light and run it through a prism, you would be able to separate out all of the wavelengths of light that come together to give you white light. So if we ran that white light through a prism, it would refract and we would see the entire spectrum of visible light, red all the way down to blue, indigo, violet. What would happen if we did the same thing with our light from lithium or our light from sodium? What would we observe if I took that light and I ran it through a prism to see what was composed of, what this light that I'm observing, what is it composed of?